In this video, I will show how to find the relative and absolute extrema values of a function given by the equation on a closed interval. So the plan is to find all the critical values, that is, find the derivative of the function and set it equal to 0, or find the values where it doesn't exist. After that, construct the sign chart of the derivative on the intervals created by the critical values, and then depending on the sign chart, whatever that sign chart is, we will determine the behavior of the graph of the function and then make a decision about whether the point is the extrema or not. So let's get started and let's find the derivative of this function. So the derivative of this function is 6x squared minus 6. 6 can be factored out, and x squared minus 1 can also be factored out, and this is a polynomial of degree 2. It is always defined, so we don't have to worry about the points where it doesn't exist. However, there are 2 points where the first derivative is equal to 0. So these points are called critical points. So next we plot the critical points on the number line, and what we want to do is identify the behavior of the graph of the function in order to figure out whether it's a relative max or mean or absolute max or mean. So this is a sign chart for the first derivative, and right above we're going to show the behavior of the graph of the function. The sign chart is for the derivative on the interval from 1 to 2. Everything is positive, so the product is positive. On the interval from -1 to 1, we can plug in just 0 into first derivative to figure out that it's negative, and from -2 to -1, both factors are negative, so the product is positive. And this corresponds to the following behavior of the graph. So it's increasing from -2 to -1, and decreasing from -1 to 1, and then again increasing from 1 to 2. And what we see here from the graph is that at -1 we have a relative max, at 1 we have a relative mean, and it's not clear what we have at -2 and 2. We could possibly have max and absolute mean at those endpoints. So let's go ahead and evaluate the function at all of these points. So f of -2 is 2 times -2 cubed minus 6 times -2 plus 3 is -16 plus 12 is -4. -4 plus 3 is -1. F of -1 is 2 times -1 cubed minus 6 times -1 plus 3. It's -2 plus 6 is 4. 4 plus 3, 7. F of 1 is 2 times 1 cubed minus 6 times 1 plus 3 is -4 plus 3, -1. And at 2 we have 2 times 2 cubed minus 6 times 2 plus 3, so we have 16, 19 minus 12, 7. So what happens at the endpoints is that the function at -2 has exactly the same value as the function at the relative mean at 1, which is -1, and the function at 2 has exactly the same output as the function at relative max at -1. So that means we're going to have absolute max is 7, and it's obtained at two values. It's at -1 and 2. Absolute mean is -1, and it's obtained by this function at -2 and 1. And we also have the relative max at -1, and we have a relative mean -1 at 1. So this is how we classified this relative and absolute extrema values of this function.